Hello, my name is Omar Hernandez, and I'm going to talk about optical illusions. First of all, the science basis on this topic is how our brain perceives the light, the reflection of ray lights, and how they reflect on any object, whichever this object is. So first of all, our brain can be focused on everything at once, so it takes shortcuts to be aware or to have the whole picture and the most important things on a picture. As an example, we can see this picture. Our brain take like the most important objects in this picture, and the scientific basis on this is that in the ancient times, the humans, our ancestors, were focused on the whole picture instead of every single object. This to have to be more to be safer and to don't be like surprised by predator or something. With this said, we can move on to some examples of how we are messed up with the light and how our brains are tricked by the light and optical illusions. Some optical illusions trick our brain or deceives into perceiving colors or shades that aren't actually there. One example of this is the match bands illusions. If you can see this image, we can see that all the bands, the gray bands, are set together, and we can say that in the top of the of each band, if we see it like this in the white way, each band has a lighter color or intensity in the band, but actually if we separate these bands, we will see that they actually the same exact color. So this is one of the main examples of how light can trick our brains or be deceived. Another important example of how our brain tricks us to see things that aren't actually there as an optical illusion is the Hermann grid. This Hermann grid basically consists that if we see as a whole picture, as I've said before, these our brain perceiving things, the most important things on the picture, we will see that there are grids and lines, these black squares. But actually, if we focus on the squares, we will see some circles or halos in the crossing lines, in the center of the crossing line. But actually, if we focus on the crossing on the crossing line, sorry, we will see that there's no circle or halo there. This is an actual example of what I've said before. This thing about our brain being focused on the whole picture instead of the little objectives or the little things in the whole picture. As I've told you before, this is as an protection or something, to be protected or be aware of the predators. Another and the last example of optical illusions. This is actually a very interesting illusion that is related to motion and to colors. So this is called the peripheral drift illusion. If we see the circles, we will see that they are moving, but they are actually don't moving, so they have no motion. The scientific basis on this example is that to our brain is way more easier, sorry, to perceive the lighter colors. So we will see that there are like green, white, and blue colors. So as a scale, our brain has like this speed of perceiving these colors. So this is the basis why our brain thinks that the circle is moving, is this have a motion, but actually is static. It doesn't have any motion. And this is one of the most interesting examples that I found, and are actually pretty funny, and actually really simple or easy to see them. So as a conclusion, I could say that don't be attached to this um, phrase, that this slang, sorry, that tells we get what we see, but we actually don't. We don't get what we see. We have to be like more aware, or perceive the whole picture, and have this orientation to detail, maybe. So basically, this is the main topic about optical illusions. Hope you like it.